Okay, now we want to talk about how will a river adapt to some kind of geological structure that it's on top of. And so, reading from left to right on the first row, the first one is going to be called dendritic. And so, in a dendritic river pattern, that means that the material that the river is going through is very uniform and horizontal. So there's no real geological structure underneath the ground, and the river is just eroding the way that it naturally will. And so it's almost like the veins on a leaf, that you're going to have a river that's going to empty into another river, and then this one's going to empty into another river, and then you might have another tributary over here that's coming in, and then another one that's coming in over here. And so it's going to kind of look like the veins of a leaf. So that's going to be called a dendritic. And so again, this just illustrates that the river is going to be going through a material that's very uniform, and this is the pattern that you're going to get. All right, the next one is going to be called a radial pattern. And then this is what's going to happen when the river is superimposed on top of a structure such as a volcano. So from the top-down view, let's say that this is the crater of the volcano, and then it slopes evenly in all directions away from it. So then that would mean that the water over here is going to want to basically go in this direction. Water that is going to be draining from this side of the volcano is going to want to go in that direction, and water on this side is going to want to go in that direction. So you can see that the river system is going to kind of like make spokes on a wheel. And so that is going to be a radial river system. Okay, then the one that's next to it is going to be called a deranged one. So this is the one that's on the top row, and it's the furthest one to the right. This is going to be called deranged, and so it's very, very unorganized. And so this commonly occurs right after a glaciation. So after the ice ages and then the glaciers, they melt back, there are no well-established river systems yet. And so you end up with this pattern of rivers that looks very chaotic. Okay, now let's take a look at on the bottom row, all the way over there to the left is going to be a rectangular river system. And so what this is going to happen is the rivers are going to be following joints in the ground caused by faults. And so often fault lines are going to offset each other, so that a river going in this direction here might be following this fault, and then it's going to make a jog like that. So the river is going to be following all of these different kinds of cracks that are in the ground caused by faulting. Okay, then the last two, the trellis and the parallel, are actually very similar to each other. It's just the direction that the river is traveling. So a trellis pattern and a parallel pattern can be made by anticlines and synclines. So from the side view, you've got rocks that are doing this, where they're making anticlines, and then where they're making synclines, and then where they're making anticlines again. So the ground is folded like an accordion. So let's say that this is the sideways view. So what would it look like from the top-down view? So from the top-down view, you would have a series of ridges. So let's assume that this material is very resistant to the flow of the water. Okay, so it doesn't erode very much. But let's assume that down here it does. So that you're going to have ridges here, which correspond to the tops of these anticlines. And then where the syncline is at, you're going to have a valley down here. And so a river then will follow in this valley thing. And so over here, you might have another river. And over here, you might have another river. And you can see that they are making parallel lines to each other. So that's going to be a parallel river system. Now, what about, though, if you took this thing and you took it and you moved it sideways? So that this time, instead of having the anticlines and synclines like this, what about if we rotate them so that you have your anticlines are going to be going sideways, and then in between the anticlines would be the synclines. And now let's have our river system again going in this direction. So you can see that it would cut across these anticlines. And then there might be tributaries that would be feeding this river system that are flowing in this direction. So this is going to make a trellis type of river pattern. Okay, what can happen if you have uplift? So that you have a established river and then you have some kind of tectonic activity where the ground is raised up. Okay, as the ground is raised up, sometimes the river can keep pace with it. And so the river will start to cut down into the structure as it is lifted up. So a classic example of this is going to be the Grand Canyon. So the Grand Canyon originally started out as a meandering river. So it was doing this, and it was moving very, very slow. But then what happened was the ground was lifted up, and as it was lifted up, this river began to speed up, and it began to cut down into that structure. So that today, you see these gigantic canyons, and you see a very fast-moving river in the bottom of it, but yet if you look at it from the top-down view, you see this meandering feature, which you would associate with a very slow river. Okay, so what this is it's an adaptation to the uplift of the surrounding area. Okay, and then one more thing here is another adaptation to uplift is going to be terraces and incised meanders, and so this is going to be called rejuvenation. So that you have an area where it used to have a meandering river, and then it had a floodplain. So on either side of this meandering river, you've got a floodplain. Okay, now what happens is that the ground is lifted up, this river starts to cut down into its former floodplain. And so what that's going to do is it's going to leave parts of this floodplain high and dry, and you're going to see evidence of where the old floodplain was, because it's going to be elevationally higher. And then so from the sideways view, you're going to have the old floodplain is up here, and then it's going to cut down, and now here is the new floodplain over here. So here's the river, here's the new floodplain, and up here is the old floodplain. So that these things are going to be called terraces. And you can have a terrace inside of a terrace inside of a terrace. And again, this is illustrated in the Grand Canyon. All right, let's take a break, and when we come back, we're going to talk about what kinds of hazards do rivers pose.